Okay, so today we're going to talk about doing some in-circuit programming on the 2003 to 2007 GM instrument clusters, '07 Classic. But yeah, here we go. We got a little Arduino Uno that I spent a week trying to figure out how to program these instrument clusters with. Um, I'm definitely not a programmer. I'm sure once I show you guys the sketch, anyone in here that's a programmer is going to be like, oh, that was trivial. Why did it take you so long? But it's the best I could do with my limited knowledge of it. So I've been testing it just in one of these little SOP8 adapters, and I have verified that it works with this, at least to read it. I actually haven't tried programming it yet, but we'll do the program in this video because I literally just finished writing this code maybe uh, hour or two ago. So let's go ahead and jump in. First, I'm going to show you how you wire it up to the EEPROM, and then I will show you the sketch, and we'll try doing a little programming with it. But this is a nice little do-it-yourself project that'll cost you less than 50 bucks, and you can start programming these things, and you can do it in circuit, unlike with this guy. So the whole reason why I got all the way into this project is I was talking to other people about the Mini Pros, and I don't have the Mini Pro 2. I have the old Mini Pro, what is this? Yeah, the TL866CS, CS, which is the older version of this, so it doesn't have the in-circuit plug on it, so I assumed that's why it wasn't working. I talked to other people that do have these, the Pro version, or the second version and the Pro version, and neither of them will do it too. They all will go into overcurrent protection on the instrument cluster, but here we don't have overcurrent protection, so it'll work just fine. That being said, you also run the risk of if you put it on backwards, you could possibly damage something because there is no overcurrent protection. Also, if you were to short some leads together, you could possibly damage the Arduino. Not very likely to damage the board because this is only the 5 volts. See, we're lucky, and the Arduino runs natively at 5 volts, and so does our EEPROM we're dealing with. So that makes it nice and easy for us. This isn't a 3.3 volt processor, so okay, so up top here you can see my very crappy drawing in Microsoft Paint, but I know this is going to be blurry, so I'll just go ahead and tell you that. Blue pin is going to be pin 13, yellow pin is going to be pin 10, and they're all in between that. So yeah, that's your pinout that you have. So you can use that. You'll also find the same image on the GitHub that I posted with the source code to this. So that way, if you want to try it, you'll have your diagram and you'll have your source code to do it yourself. All what you need is an Arduino Uno and either one of these adapters to do it in circuit or one of these little guys to do it out of circuit, where you can just take it off, shove it in the breadboard right there, and do it that way. Okay, so let's take a look here at the sketch, as they call them in Arduino. This is just going to be the code that goes onto the Arduino. It's basically C Sharp, if you're familiar with it. I'm not. I'm not familiar with C Sharp at all. All of my experience with it is just playing with some of the example codes for an Arduino and trying to do some other stuff with it. So let's go ahead and take a look at what we're doing here. So first, I have to thank some members of the Arduino forum. JML, he wrote the hex function. I asked some questions. I didn't know what was going on, and he just wrote that for me. So big thanks to him for doing that. Jay Remington for really calling me out for being an idiot. There were a couple of times I asked some questions about the particular EEPROM, and he was like, you provided the data sheet, because I did. I loaded it. Read it, because all the questions I asked, the answers were in there. So thank you to him for, smacking me upside the head and get back to work. And then Chuck Todd, back in 2015, he wrote the read function for this particular EEPROM for somebody else. So the read function was already on there. I didn't have to write that. So next, we're going to go down. We're going to include SPIH, which that's like including a library if you're familiar with Python, and then define CS pin. So we're telling it which pin is the chip select pin, and so then we have to define some opcodes just so that way we don't have to type out the opcode every time we need to use it. here's that function I was telling you that they wrote that turns ASCII, which is what's going to come across the serial monitor. So let's go ahead and pull up the serial monitor so you see what I'm talking about. So when you are talking to the Arduino, so there you go. It's send. This is part of the code you'll see later. So then when you send anything across like this, you're gonna then get which that's just erroneous because it's not plugged into an EEPROM at all. So then you send a bit across. That bit's going to be interpreted as ASCII by the EEPROM because that's how it's being sent across here, because this is an ASCII monitor. So let's go back down there into the code. So everything being sent in is ASCII, and we got to turn it back into hex. This will make more sense in a minute. And then we have the SPI read function that I didn't have to write, but I have a pretty decent understanding of what's going on with it. So this is where it's the function being defined, and then we have SPI begin transaction, where we're going to tell it, hey, we want to work at, I believe that was 4 megabytes per second, and then it's most significant bit first, because you can have big Eden or little Eden, which is most significant or least significant bit first. Then we have SPI mode 0. There's 4 different SPI modes. I'm not going to get into what the 4 different ones are. They really don't matter here. All we know is we need to use SPI mode 0 for this, so we're going to use mode 0. So then to do the read command, all you should do is pull chip select low. Then you're going to send your address. So this is going to do like a bit shift, send the address to it, and it's going to send the read command at the same time. Then SPI transfer 0 is it starts reading back what's being sent, because you're going to send the bit and the read command, and then after that the Arduino will start. Sorry, not the Arduino. The EEPROM will start sending back the data that's on that address that you commanded it to do, and then here's it actually reading it, and then because this is actually sending the thing, this is reading it, and then after it reads it, you just pull the chip select high so it knows that it's time for a new command. So chip select goes high, it means the chip's not in use, and then chip select low means chip is in use to the EEPROM. It's just communication to the EEPROM. So then here is the function that I wrote based on that one, which is to write a bit, and it's going to write 1 bit at a time. So first what we have to do is same thing, define how this SPI transaction is going to go, same as before, and then we're going to go chip select low, telling it, hey, we're giving a command, we're going to send it the command write enable, which is WREN, and then which that is just 6, so we're going to send it a 6. And then you're going to pull it back high, because that's in the data sheet. When you look at the data sheet, it says write enable, pull it high again, pull it low again, send the you're going to send your address and the write command, and then followed by the write command, you're then going to send the data it's writing. I didn't change that to say write, but that should say write, the actual bit, and then transfer high. I put a 15-second delay on here. Really, what I should have done is took the time to figure out how to do the op. There's an opcode that you send it, and it's asking, hey, are you busy writing? Because there is a delay in between each bit being written, and so you just say, hey, are you busy writing? And it'll send a 1 or a 0, and if it's 0, it's not busy writing, and you can write the next one. I was too lazy to write that. I just gave it a 15 millisecond delay, because it looks like it's supposed to take at maximum 10 milliseconds. So I was like, 15. Because that makes the write time of this like 2 seconds to do the entire thing anyway, so it's not that big of a deal. And then you just end transaction. Alright, so let's get down here into setup. So we're set up. We're going to define our baud rate for serial, just that way we need that to match in the COM port. So your baud rate here needs to match whatever you put there. I just use that. It's a pretty common baud rate, nice and in the middle. And then we're going to make sure that nothing got if for some reason the Arduino was pulling it low when it booted up, we're just going to go ahead and pull it high. So that way the chip knows it's not being given any commands anymore. And then just the pin mode for it. All right. So let's get down here into the meat and potatoes of this. So this is just to tell it, hey, it's a serial print line. It's just going to print a line on there. And let's get down here, though, where the interesting stuff happens. So we're going to give it serial available loop here. Well, not a loop, but an if statement. And then serial read. So this is where it's going to read that 1 or 2 that you're going to send to let it know what to do. You send it the 1, and it's going to, and this is where it's listening for it. And so it says, if letter 1, then do this, which is the read command. This is where it just calls the function and gives the, so we're going to just use a for loop right here, going to integer 256 because it's a 256 byte EEPROM, and then we will come down here. Sorry, not go down there. So then, yeah. So we're doing our for loop. It then calls the read byte command. That read byte command's gonna give it the ch there, and there you go. We can then print the character because character is for loop doing its thing, calling the function at the same time. If that makes sense. I know I'm kind of oversimplifying this, but yeah, this 256 right here is going to define how deep. So if we were using a different EEPROM that used the same opcodes and everything, so if we were using one of this EEPROM's brothers, because there's a couple other ones in the series that are larger that they respond exactly the same way. So we would just change that to, if it's like a 512-bit EEPROM, we just change that to 512, and it would read to 512. So that's really the read function. Pretty simple. I've actually showed this before in a different video. Now let's come down to the write function. So the write function, we're going to paste bin in 7 seconds. So the reason why is we have the serial timeout here set. If you don't set a serial timeout, it's 1 second. I found 7 seconds fast, like plenty of time to copy paste your bin that you want to use and send it through the terminal to it. So again, you're going to just copying the bin, and then you're going to just paste it up here and then click send, and then if you send it at second 1, you just have to wait 6 more seconds and then it'll do the command. So yeah, you'll send it and then it'll just run the command. So first thing we have to do is turn that 512 ASCII characters back into 256 hex characters, because it's going to come across as ASCII. So we have a for loop right here that does some math that I don't really understand, turning it back into going from the ASCII back into hex. I kind of got how the function works. I don't necessarily get how it turns them into a byte. Somebody else wrote this for me, and it just works. So if somebody knows why this works, please comment down below and explain it to me, because I do want to learn more of this stuff. I'm very interested in it. I'm not interested in becoming a programmer, but I'm interested in being competent enough in doing more of this kind of stuff. I really like it. So yeah, so then we've turned the ASCII back into hex, and so now it just becomes dump I. So the dump I, it's just an array of all of the data. So now we have that array called dump I that we can then do another for loop very similar to the one for read command, but does the write command. We just have to add one extra thing here, which is dump I, that we don't have. We just have CS pin and I there. We're going to just do CS pin I and dump I. So I is what iteration of the for loop we're on. Dump I means we're going through that array, so we're going to pick what iteration of the loop we're on in that array and send it up to the function, and then the function will do its thing and write it in there. If that explains it. That's the best way I can explain what's going on in here, because I'm not a programmer, like I said. But hopefully this all makes sense to you. I hope you've learned something from this. Let's move on and actually do some programming and do what you all came here to do. Okay, so here we have a instrument cluster. Let me just go ahead and zoom this out so y'all can see better. Alright, so we got a random instrument cluster that I haven't finished repairing that I own. It's just one I got from the junkyard. So let's go ahead and hook this up. It's real complicated. You know, we got to take this off. Oh, never mind. We're just going to plug in. We're not going to pull the whole thing off. So we're just going to take this guy and set her on there. I believe we got good contact on all the legs. Let's try again, though. That looked a little crooked. The, these are kind of a pain to put on there, but it's easier than having to pull it all the way off the board. So now we're plugged in. I guess I'm going to unplug it again. Let me go ahead and boot it up so you can see what's currently on here mileage-wise. And get rid of that. And we have 364,000 miles on here. So let's go ahead. I've got a random bin sitting on the computer that I really don't remember what the mileage is on it, but we're gonna go ahead and hook that up to it and flash it on there. So let's put this guy back on here for the third time now and see if we can get a good read off of it. So we got it hooked up there. Let me just switch you back to the to the monitor so you can see what's going on, because there's nothing really to see now that it's plugged in. So let's switch back over to the screen and see what's going on there. Okay, so now we are in the Arduino. Let's pull up the tools here. We already have the Arduino plugged into the computer. I know I wasn't showing that on the camera. Serial monitor. And okay, press 1 to read or 2 to write. So we're just going to go ahead and read it real quick. And that looks like a good read to me. So let's look at the beginning. So 37A5, and yep, it's repeating. So we got a good read off the EEPROM. Now we're going to have to write to it. So here's that random bin I told you about. First thing we got to do is copy it into a text document. It's just easier to work with it like that. So paste, and then edit, replace all, and we're just going to replace all the spaces with nothing. So place all. There we go. We've replaced them all. Now let's copy that. So I just hit Control C there to give it a good old copy there. Let's hit 2 so that way we can write to the EEPROM. So we're going to hit 2, and it says paste in 7 seconds. So we're going to go ahead and send that. Alright, so it looks like a bunch of gibberish right here, but that is because it is sending back the hex that it's writing to it instead of ASCII back to us. So then the computer is just giving the text interpretation, or the ASCII interpretation of those hex values. So now let's go ahead and let's just hit 1 again and see if we got something different written on there. So we ran that again. Let's get back to the end of that gibberish. And okay, so we have 2903, 2903. Let's see if that's what we got over here. 2903. Yep, that looks right. So looks like we got a good read. So let's go ahead and unplug the Arduino from the board, boot it up, and see what we have. So before you turn back on the instrument cluster, you're going to want to unplug this because the 5 volts that's going to power the chip is going to come back in here and power this. I haven't tried to see what will happen if I power it up like that. I don't really want to damage anything. I would imagine that the extra load of this may not be good for whatever 5-volt rail this is on. So we'll go ahead, just unplug the programmer. We don't have to solder it back in because, again, we did it in circuit. This is so much better than going with the out of circuit method. Doing these in circuit, I do enjoy it. It is nice and easy. So let's go ahead and power it up and see what we get. So we're going to turn on the power here. And do we get odometer error? Let's see. No, we get 268,000 miles. So that's how much is on that dump. I should probably write it on there so don't forget it. But yeah, there we go. That's all there is to it. You plug this guy in, plug this guy in first. You're going to program this thing, then you just plug it in, run some stuff through the serial monitor, and you can program these things in circuit, no problem at all. We don't have to worry about any overcurrent protection. Um, if I were to take some time, I would probably put some resistors in here so that way you're not going to just smoke everything if you hook it up wrong. But I already spent a week doing this, and I haven't made any other content because I was spent so much time doing this one. So please, please, if you found this useful or helpful, please share my videos with your friends. Let them know, hey, look at what this guy can do. Let's learn it together. Let's learn how to do these repairs together, because that's what this is all about, is teaching other people how to do it. So if you see these, don't keep it a secret. Share it with your friends. Let them learn too. Um, Because, man, I really would like to grow this channel some more and get some more people involved in this, because honestly, the more people that are involved in this kind of community, the more we all learn together. So here is my contribution to everybody. I'm going to put a link down in the description of the GitHub where you can download the information you need to do this. I'll put some Amazon links to this Arduino board and the breadboard and the this cheap connector. This is a cheap connector. I would recommend buying a better one than this, but this one's nice and cheap. So if you just want to try it out, see if it works for you, and then buy a better connector down the road, that's what I would do. And you can still do this stuff out of circuit. If you're not comfortable with doing it in circuit, you can still do it out of circuit with something like this. Just plop this in there instead of that, and you're good to go. I'll probably also later on design a full-on kit to put it all together that's not an actual Arduino board, so that way it looks a little more professional, especially if you are one of those people that have a lot of people sitting down watching you do these repairs and you don't want them to see this come out to work on their instrument cluster. I'll come up with a kit that's a little bit better and presentable to people. Maybe if somebody likes to do some 3D printing, they can design me a little box to put it in. And let's go ahead and subscribe to the channel if you haven't already. I'll see you guys in the next one.